Imagine choosing not to eat for a full day. At first, it doesn't feel like much more than skipping breakfast or pushing lunch a little later. But underneath that simple choice, your body is already undergoing a powerful shift. Deep inside, your organs begin switching modes, moving into a state they rarely enter in a world where food is always available. The first few hours of fasting are like a test for your system. Your body has to decide how to manage and prioritize its limited fuel reserves. Even though your stomach is empty, it doesn't fully stop. Digestive juices continue to be released almost out of habit, as if expecting food that never comes. At the same time, your hormones start to change, sending signals to your brain that conserving energy is now the main priority. It's almost like an internal switch being flipped. By around the 4th hour, hunger hormones like ghrelin rise sharply. This is what makes you feel hungry even if your energy levels haven't actually dropped. Your body is simply reacting to the disruption of its usual routine, interpreting the absence of food as something urgent. But what feels like discomfort is actually the beginning of a deep biological adjustment. From this point on, your body starts reorganizing itself. It's as if every organ has taken a new role in a coordinated survival system, all working together like an orchestra. And at the center of it all is your metabolism, quietly conducting these changes in the background. Around 6 to 8 hours into fasting, your blood sugar begins to fall. For many people, this is when fatigue, irritability, or even headaches can appear. It feels like an energy crash, but on a biological level, something important is happening. Your body is transitioning away from its immediate fuel source. Glucose in your bloodstream starts running low, and in response, your pancreas reduces insulin output. Since insulin helps move sugar into cells, this drop means your body can no longer rely on a constant flow of carbohydrates for energy. Instead, it turns inward and signals the liver to step in. At this point, stored glycogen becomes your backup supply. The liver begins breaking it down and converting it into glucose to stabilize blood sugar levels. It's a carefully balanced process. If too much glucose is released, energy is wasted. If too little is released, your brain quickly makes you feel it. This delicate regulation is what creates that strange mix of tiredness and alertness at the same time. It's the earliest stage of survival mode, laying the groundwork for what comes next. If you're finding this process interesting and want to understand how the body continues to adapt during fasting, you might want to keep learning more about it because the changes only become more fascinating from here. By around the 10th hour, your liver takes on an even more important role. It continues managing blood sugar through glycogen breakdown, but it also starts preparing for a deeper metabolic shift, fat utilization. This flexibility is essential for human survival. Without it, our ancestors would not have been able to endure long periods without food. The liver is often thought of as an organ for detoxifying substances like alcohol or medication, but during fasting, its role becomes even more critical. It essentially acts like a biochemical control center, keeping your brain supplied with energy even when no food is coming in. As glycogen stores continue to decrease, the liver begins producing ketone bodies from fat. These ketones become an alternative fuel source, and your brain adapts to using them very efficiently. In fact, many people report increased mental clarity during this phase, which may be linked to how ketones affect brain energy metabolism. This is a major turning point. Instead of resisting hunger, your body begins shifting toward fat burning as a natural and efficient strategy, with the liver driving this transformation. Inside your cells, tiny structures called mitochondria act like power generators. During fasting, they are pushed to operate more efficiently, extracting as much energy as possible from limited fuel sources. This adaptation at the cellular level is one of the reasons fasting has been studied in relation to longevity and metabolic health. Your cells also shift their form of respiration. With less glucose available, they begin relying more on fat-derived fuels. This process produces fewer waste byproducts compared to constant high glucose metabolism, meaning your cells function in a cleaner, more efficient way. This is also the stage where autophagy begins to activate more noticeably. In this process, damaged proteins and malfunctioning cellular parts are identified, broken down, and recycled. It's essentially a deep internal cleaning system, clearing out old or inefficient components so the body can operate more effectively when normal eating resumes. In simple terms, fasting pushes your body out of constant consumption mode and into repair mode. It creates a biological reset that modern eating patterns rarely allow. By the 12 to 14-hour mark, insulin levels drop even further. With low insulin, fat metabolism becomes much more active. Fat cells begin releasing stored energy into the bloodstream, making it available for use. This is one of the reasons fasting is often linked to improved insulin sensitivity. Over time, the body becomes more efficient at responding to insulin when food is reintroduced, which may help reduce long-term metabolic risks. But this phase also comes with a challenge. Cravings often intensify. Your body is adjusting to a new energy system, and it may push signals that encourage you to eat again. If you continue through this phase, fat burning becomes more stable, and your energy levels begin to balance out once more. Insulin's decline represents a major internal shift. It marks the point where your body fully exits the fed state and officially enters the fasting state, where survival-based biochemistry takes over and energy management becomes the top priority. By around the 15th hour, your stomach has already emptied, yet it continues its normal rhythm of producing acid and digestive enzymes on schedule. This ongoing activity can create that familiar hollow rumbling sensation, often felt as a growl. It's essentially your stomach contracting and signaling expectation, even though no food arrives. This isn't harmful. It's simply your body operating on a long-established routine that assumes regular meals. As the fast continues, the stomach gradually begins to settle into rest. This pause in constant digestive activity can actually be beneficial, as it gives the gut lining time to recover and reset. Modern eating habits, especially frequent snacking or late-night meals, often interrupt this natural downtime. Research suggests that fasting windows may help reduce inflammation within the digestive system. Some people with conditions like gastritis or irritable bowel syndrome report that symptoms feel less intense during structured fasting periods. While fasting is not a treatment or cure, it highlights how valuable rest periods can be for the gut. Even in silence, your digestive system is still working, repairing, restoring balance, and preparing for future meals more efficiently. Around the 17th hour, changes in mental state often become noticeable. Some people experience a sudden boost in focus and clarity, while others may feel more irritated or restless. This contrast comes from the brain adapting to ketones as an alternative fuel source. Ketones do more than simply provide energy. They also interact with brain chemistry, influencing neurotransmitters that affect mood, alertness, and cognitive performance. For some, this can feel like a natural mental boost, similar to the stimulation of caffeine. From an evolutionary perspective, this makes sense. When early humans were in a fasting or low-food state, increased alertness and sharper focus would have improved their ability to hunt, gather, and survive. Fasting appears to activate this ancient survival mode. However, the experience is not identical for everyone. If your body is not yet adapted to fasting, you may instead feel anxious, foggy, or irritable. Factors like hydration, sleep quality, stress levels, and metabolic flexibility all play a role. There is no universal response. Your nervous system determines how smoothly you handle the transition. Ultimately, fasting resets your brain's energy rhythm. Whether that shift feels productive or uncomfortable depends on how well your body adjusts to using alternative fuels. By the 18th to 20th hour, fat becomes the primary energy source. Triglycerides stored in fat cells are broken down into free fatty acids, which circulate through the bloodstream and are used by muscles and organs for fuel. This is the true metabolic fat-burning phase of fasting. The liver plays a central role here as well, converting a portion of these fatty acids into ketone bodies to ensure the brain continues receiving steady energy. After nearly a full day without food, ketones can supply a significant portion of the brain's energy needs, in some cases up to about half. This metabolic state is one reason fasting is often explored in research related to brain health and neurological conditions such as epilepsy and Alzheimer's disease. At the same time, fat breakdown also produces glycerol, which the liver can use to generate a small amount of glucose. This is important because certain cells, like red blood cells, cannot use fat or ketones for energy and still require glucose to function. This balance ensures that every system in the body remains supported, even during extended fasting. This carefully coordinated process is one of the reasons fasting is frequently discussed in the context of weight management. But beyond fat loss, it reflects a deeply evolved survival mechanism, an ancient energy system built to keep the body functioning during periods of food scarcity. Your heart is also deeply involved in this fasting shift. By around the 20th hour, it often begins working with greater efficiency. With insulin levels lower and blood glucose more stable, the cardiovascular system can experience reduced strain. In some cases, this is associated with lower blood pressure and decreased inflammation within the blood vessels. Some research also points to improvements in heart rate variability during fasting. This is an important marker of how flexibly your heart responds to stress. A higher variability is generally considered a sign of better resilience, meaning your body can handle physical and emotional stress more effectively. However, this process is not entirely without sensitivity. During extended fasting, electrolyte levels can temporarily drop, which may influence heart rhythm in certain individuals. This is why proper hydration, and in some cases mineral intake, becomes especially important during longer fasts. Without it, symptoms like dizziness or heart palpitations may appear. Overall, the heart tends to adapt smoothly, finding a new rhythm that balances endurance with efficiency. Even in a fasting state, the body ensures that circulation remains steady and reliable, prioritizing the constant delivery of blood where it is needed most. By the 22nd hour, one of the most important biological processes becomes more active: autophagy. This is the body's internal recycling system, where damaged proteins, worn-out cell parts, and cellular waste are broken down and reused. It is essentially a deep cleaning process at the microscopic level. Under normal eating conditions, autophagy remains relatively low because cells are constantly focused on processing incoming nutrients. But during fasting, this constant demand drops, allowing cells to shift into repair mode. They begin clearing out internal damage and reorganizing themselves for better efficiency. Autophagy has been linked in research to improved immune function, reduced disease risk, and potential longevity benefits. Animal studies in particular suggest that fasting-related autophagy may help extend lifespan by maintaining healthier and more efficient cells. While human research is still evolving, the findings are promising and widely studied. This cellular cleanup is one of the key reasons fasting is viewed as more than simply skipping meals. It represents a structured biological reset that affects the body at a fundamental level. By the 23rd hour, changes also begin in the gut microbiome, the trillions of bacteria living in your digestive system. Without a constant stream of food, the balance of bacterial populations begins to shift. Some species decrease in activity, while others that thrive in low-food environments become more dominant. This shift can influence digestion, immune response, and even mood regulation. Studies suggest that fasting may increase microbial diversity, which is often associated with better overall health. A more diverse microbiome is linked to stronger immunity, improved digestion, and reduced inflammation throughout the body. During this period, the intestinal lining also gets a chance to recover and strengthen. This barrier plays a crucial role in preventing harmful substances from leaking into the bloodstream, a condition sometimes referred to as leaky gut. By allowing the gut to rest, fasting may support a healthier and more resilient intestinal barrier. So even though digestion slows and the gut is empty, it is far from inactive. It is reorganizing, repairing, and restoring balance in ways that influence the entire body. Another notable change that appears around this stage is a rise in human growth hormone, HGH. After roughly 24 hours without food, HGH levels can increase significantly, sometimes several times higher than normal. This hormone is often associated with muscle growth, but its role is much broader. It supports tissue repair, helps mobilize fat for energy, and contributes to overall cellular recovery. Because of this, fasting is sometimes described as a repair state for the body. Interestingly, this increase in HGH is not dependent on exercise or sleep. It is triggered directly by the absence of food intake. In a way, it reflects the body's attempt to preserve lean tissue while encouraging fat utilization for energy. For researchers, this hormonal response is one of the clearest examples of how fasting enhances physiological resilience and adaptation. A common concern about fasting is muscle loss. Many assume that without food, the body will quickly break down muscle for energy, but the reality is more balanced. Within the first 24 hours, muscle breakdown is minimal. The body prioritizes glycogen stores and fat metabolism before turning to protein. Muscle tissue is generally preserved during short-term fasting. Growth hormone also plays a protective role during this period, helping reduce the risk of muscle loss. What people may notice instead is a temporary drop in strength or endurance, especially during intense activity. This is not due to muscle damage, but rather reduced glycogen availability in the muscles, which limits quick bursts of energy. In fact, many athletes use controlled fasting strategies while maintaining muscle mass and reducing body fat. Reaching the 24-hour mark is a significant metabolic milestone. By this stage, the body is fully engaged in fat metabolism, ketone production, hormonal adjustment, and cellular repair processes. It is operating in a state that feels very different from the constant fed conditions most people experience daily. However, fasting is not suitable for everyone. Individuals with conditions such as diabetes, heart disease, or other medical concerns should only fast under professional supervision. For others, it can serve as an insightful metabolic reset, but it should always be approached with awareness and respect for the body's signals. This balance between benefit and risk is important. While a single 24-hour fast may offer metabolic advantages, making it a regular practice requires careful planning and individual consideration. From a scientific perspective, a well-managed 24-hour fast activates several key survival pathways: fat burning, autophagy, hormonal shifts, and neurological adaptation. Rather than being about restriction, it highlights the flexibility of human metabolism. At the same time, fasting is not a cure-all. It should never replace fundamental health pillars like balanced nutrition, quality sleep, and regular physical activity. Instead, it can be viewed as an occasional tool to give the body a structured break and allow natural repair systems to function more freely. Ultimately, a single day without food reveals just how adaptable and intelligent the human body truly is. What feels like simple hunger on the surface is actually a coordinated biological transformation happening beneath it. And whether or not someone chooses to fast again, the science behind it shows how dynamic and responsive the body really is.